Hello, everyone, and welcome to day 8 of Jamb Physics in 40 days. I believe you've been enjoying the series so far. To those who have been part of the series from day 1, Jamb Physics in 40 days is a series brought to you by Oya Learn, where we believe that when you dedicate 30 to 45 minutes of your time daily, you get all the necessary skills and tools that you need to ace Jamb Physics. So if you are a Jamb candidate preparing for the exams and physics is one of the subjects that you have chosen to write in the exams, then this video is definitely for you. So please go on to check the video from day 1 till this present one, which is day 8. Trust me, you don't want to miss any of those videos, because in each of the videos, we not only give a crash course to individual topics that are discussed, we also solve past questions on those topics. So please do well to check from day 1 till this moment so that you can also get all the knowledge that has been learned from those videos. And then, as always, don't forget to like, share, and subscribe to the channel. And this is day 8, where we'll be discussing simple machines. Now, for every Jamb candidate, what is expected of you before the exams on simple machine is that you should be able to first identify different types of simple machine. Now, you know a simple machine is a mechanical device that makes work easier, right? And there are different types of it. I've listed the types of machines we have here. We have the lever type machines, we have inclined plane, we have wheel and axles, we have pulley systems, we have screw and wedge. These are the types of simple machines we have. However, there's a particular question that you could be asked to identify the class of lever that we have. So when we take a lever, for example, every lever has what we call the fulcrum. Another name for fulcrum is pivot. It also has load and then effort. Now, the position of this on the lever determines whether it is a first order lever, second order lever, or third order lever. Now, the first order lever, for example, the scissors, it has the pivot. When the pivot is in the middle, then this is what? The first order lever. And I gave example like in the case of scissors. Now, when you consider the scissors, the pivot of the scissors is at the middle. The load is put between the blade and the effort is between the handle, right? So you have load, you have fulcrum, and then effort. So that is why it's called the first order lever based on that arrangement. Now, in the case of the second order lever, an example of that is the wheelbarrow. For the wheelbarrow, the load is in between. When the load is in the middle, like in the case of a wheelbarrow. Now, you see that the fulcrum is the tire, and then the load is that basin where you put your whatever you are carrying, and then you apply the effort at the handles. So the load is in the middle. So in this case, you have what we call the second order lever. And then when the effort is applied in the middle, you have what we call the third order lever. And an example of a third order lever is your forceps. Now, when you consider the forceps, you see that this is what the forceps looks like. This is where you pick a load. You apply your effort at the middle here. This is where you apply your effort. And then this is the pivot here. So this is a forceps and it belongs to the third order lever. So that's one of the things you must be able to identify when it comes to different types of simple machines. And then another thing they expect for every candidate is to be able to solve problems involving simple machines. Now, here are some of the things you should know before you can solve problems on simple machine. You should know that for every simple machine, the efficiency is not 1, because friction will affect the efficiency of a machine. And the efficiency of a machine is given by as mechanical advantage over velocity ratio. And then you should also know that mechanical advantage is the ratio of load to effort applied, right? While velocity ratio is given as distance moved by effort by effort over distance moved by load. Now, here is the common challenge with solving, especially when it comes to velocity ratio. Now, for simple levers like this, we can use this equation easily without problem. But as you move on to different types of other machines, there are other ways you can derive the velocity ratio of such machine and still following this particular equation here. Like for example, in the case of inclined plane, if you're asked to find the velocity ratio, if you don't know the distance moved by effort and you don't know the distance moved by load, you can apply another equation where we say the velocity ratio for inclined plane is given as 1 over sine theta, where theta is the angle of inclination of the plane, right? So this is another equation for velocity ratio, and this works only for inclined planes. Now, when you come to wheels and axles, the velocity ratio in this case can be derived as the radius of the wheel over the radius of the axle. You could also use other parameters like diameter. For example, diameter of the wheel over diameter of the axle. It also works in that case. And then for the case of pulleys, the velocity ratio is given as the number of single pulleys in the system. For example, if you find a question which says a block and tackle system consisting of 6 pulleys is used to perform a particular work now, for example, in that case, that block and tackle system has 6 pulleys. So the velocity ratio is easily 6 in that case. If it is 4 pulleys, the velocity ratio will be 4. If it is 3 pulleys, the velocity ratio will also be 3. And it goes on like that. Then in the case of screws, the velocity ratio can be derived to be given as the circumference, that is 2 pi r, over the pitch length. That is the length between the individual grooves of a screw. If this is a screw, for example, right? So you find the circumference of this head here, and then the distance between this is what we call the pitch, right? So circumference over pitch is how we find the velocity ratio of a screw. And then in the case of a wedge, the velocity ratio is given as the length of the wedge over the thickness. So these are the basic things that you should be familiar with, but for a fuller understanding, you can check out our video on simple machines. We have done well to explain it even a lot more with all these derivations done in that video. But for now, let's just go on to solve past questions from Jamb on simple machines. And also, don't forget to like, share, and subscribe. Now get your materials and let's solve some problems. This question from the 1999 UTME exam says, the figure above represents a frictionless pulley system in which a weight W is in equilibrium with a weight of 40 newtons. So find the value of W. Now, when we take a look at the figure provided, we see that the system consists of 2 pulleys, right? So what can we tell from what the question has given us and what the diagram is also telling us here? Now, first, we know that it is a frictionless pulley system. That tells you that the efficiency is 100%. Okay? And we can also see from here that there are 2 pulleys. So velocity ratio equals 2, right? Now, from this, let's then use the equation for efficiency to finish it up. So efficiency, which is 100%, that's 100 over 100, that will give you 1, equals mechanical advantage, which we do not know yet, over velocity ratio, which is 2. So what this implies is that the mechanical advantage is also what? 1 times 2, that will give you 2. But mechanical advantage equals load over effort, right? So what this implies is that 2 equals the load. The load has weight W, and the effort applied is 40 newtons. Now, what does this mean? It means W equals 2 times 40 newtons, and that will give us 80 newtons. So the correct answer is option D. This question from UTME 2009 says, if a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, then its velocity ratio will be, and at the beginning of the video I did mention that when you have inclined plane, we know that velocity ratio is supposed to be distance moved by effort over distance moved by load. But when you are not provided with those information, there is another equation you can use to find velocity ratio for inclined plane. And that velocity ratio is given as 1 over sine theta, where theta is the angle of inclination of the plane. So in this case, velocity ratio is therefore 1 over sine 30 degrees. Now this will give you 1 over 0.5, since sine 30 degrees is 0.5. And of course from here, velocity ratio is therefore 1 divided by 0.5 will give you 2.0. So the correct option is D. The figure above represents a frictionless pulley system, in which a weight of W is in equilibrium with a weight 40 newtons. So we have to find the value of W. Now, let's see what we know from this question here. First off, we know that it's a frictionless pulley, and in a frictionless pulley, efficiency is 1. So that is 1 equals mechanical advantage over velocity ratio. And what this implies is that velocity ratio equals mechanical advantage. Now, that is said. Now, another thing we can see is that in this system of pulleys, we have 2 pulleys, right? So, and the number of pulleys indicates the velocity ratio. So we can also say that velocity ratio equals 2. Now this implies that mechanical advantage will also be what? Since it's a frictionless pulley, mechanical advantage will be 2. Now, all we have to do is find W. Now, when we look at this pulley system, we see that the load attached to the end of the pulley is 40 newtons. This is load. And the effort applied that is at equilibrium with load is W. So the effort is W. And what is mechanical advantage? Mechanical advantage is load over effort, right? So to find effort, this implies that effort will therefore be load over mechanical advantage. So what's the effort? Effort is W equals load. The load is 40 newtons divided by the mechanical advantage, which is 2. Now, 40 divided by 2 will give us 20 newtons. So, from the options provided, we go with option B. A machine of velocity ratio 6 requires an effort of 400 newtons to raise a load of 800 newtons through 1 meter. Find the efficiency of the machine. So, let's solve. First thing you want to do is write out all the information we are given. So velocity ratio is given as 6. Okay. Effort is given as 400 newtons. And load is given as 800 newtons. From this, we can get our mechanical advantage. And that will be load over effort. So let's do that here. The load is 800 newtons over effort, which is 400 newtons. This would give us 2. So now we have mechanical advantage, so let's find efficiency. So the efficiency would therefore be mechanical advantage over velocity ratio multiplied by 100%. And that will be 2 over 6 times 100%. And that will give you 200 over 6 in percent. 6 will go in 20 3 times, remainder 2. In 20 again, 3 times, remainder 2. So that's 33.33 The correct option therefore is C. This 2080 TME question says the efficiency of the pulley system shown above is 80%. Find the effort E required to lift a load of 1,200 newtons. Now, folks, before I go on to solve this problem, I want to encourage you to please subscribe to the channel if you are yet to be subscribed. When you subscribe, you are helping us to be able to make more helpful videos like this. So please ensure you subscribe. It will only take a moment of your time, just within a second, and you've already clicked the subscribe button. So please do so, and also hit the notification bell icon so that you get alerted every time we put out a new content for you. And also do not forget to check out the Exam Fund app. The link to download it is also in the description box. You can follow the link to download the Exam Fund app and make your learning experience very much fun. Thank you very much in anticipation of doing this. Now let's go to the question. From this question, let's gather out the facts that we have. We are told that the efficiency is 80%. So efficiency is given. Another thing we are told is the load. Load is 1,200 newtons. We do not know the effort, so that's what we have to calculate. But we know that this pulley system has 4 pulleys in the entire system. So 1, 2, 3, 4. And that tells us that the velocity ratio is also going to be 4. So we can apply this to solve for effort. Now, originally we know that efficiency equals mechanical advantage over velocity ratio, right? So in this case, we can then make mechanical advantage the subject, but note that mechanical advantage is load over effort. So let's apply that. So if we do that, we cross multiply here, then we'll have velocity ratio multiplied by efficiency equals load over effort. So let's use this to solve. Velocity ratio is 4. Multiply that by the efficiency, which is 80%, so 80 over 100, equals load, which is 1,200 over effort. So from here, what this implies is that we can break this down and say 80 over 100 will give us 0.8. 0.8 times 4, that will give us 3.2. 3.2 equals 1,200 over effort. So from here, we can now say the effort is 1,200 newtons over 3.2. And this would give us 375 newtons. So the correct answer in this case is in option C. Now, in this question, we are to find the value of W, that is the effort required to pull this load of 120 Newton in this block and tackle system, which consists of 6 pulleys. So let's solve it. Now, the efficiency of the system is given as 40% according to the question. And so efficiency, which if we're applying the formula efficiency, equals mechanical advantage over velocity ratio. You know, from here we can break this down and then say efficiency equals load over effort divided by velocity ratio. So let's apply that. Efficiency is 40%, so that will be 0.4 equals load 120 newtons over effort, all divided by velocity ratio, which will be 6 because we have 6 pulley systems here. So what this implies is that 120 newtons divided by effort equals 6 times 0.4. So from here we can then say the effort is 120 newtons divided by, now this comes down, so we have 6 times 0.4, which will give us 2.4. And when you divide this, you get 50 newtons. So the effort required is 50 newtons. And when we look at the options provided, that is in option C. Which of these is the second class lever? Now, another name that could be used in place of second class is to say second order lever, right? And at the beginning of this video, I did mention that for levers, we have three classes or three orders: first order, second order, and third order. And then I gave examples, one example of each. And I told you how to identify whether it's first order, second order, and then third order lever. Now, coincidentally, one of the examples I gave for your second order, the example I gave for second order lever is in this question. It's part of the options, and that's wheelbarrow. So we know that the answer to this question is option D. But let's look at the other options and tell which order they belong to, because the question could come from any direction. You could be asked to identify the first order, the second order, or the third order. So in this, the first option we have here is the sugar tongs, which is just like the forceps we use. And when you consider that, you see that the arrangement in that case is that we have the fulcrum, then we have effort, and then we have load. This tells us that it is, when the effort is in the middle, it is third order. Third order. For the case of claw hammer, the arrangement for that is load, then fulcrum, then effort. Now, when the fulcrum is in the middle, that is first order lever. Then for plier, the arrangement for plier is also the load, then we have the fulcrum, then the effort. So it is also a first order lever. And then finally the wheelbarrow, which has the fulcrum, the load, and then effort. So because load is in the middle in this case, it is a second order lever. So there we go. The correct answer is option D. Let's solve this 2024 UTME question. It says the mechanical advantage of the machine shown is, and the machine we see here is a wedge, right? So in this case, we are going to assume it to be a frictionless wedge. So, and when we say it's frictionless, that implies that the mechanical advantage equals velocity ratio. And for a wedge, the velocity ratio is given as the length of the wedge divided by the thickness of the wedge. So we can then say our mechanical advantage equals, now the length of the wedge, which is this part that is given, so we have 15 centimeters divided by the thickness. The thickness is 0.5. So centimeter cancels centimeter. Mechanical advantage can then be written as, this can be written as 150 divided by 5. And this will give you 30. So the correct answer here is option C. A load of 300 newtons is to be lifted by a machine with a velocity ratio of 2 and an efficiency of 60%. What will be the effort applied to lift the load? Solution. From our efficiency equals mechanical advantage over velocity ratio, we can then make mechanical advantage the subject. So that will be the product of velocity ratio and efficiency. Our velocity ratio is given as 2. Efficiency is 60%, so 60 over 100. This would give us 120 over 100. Now, mechanical advantage is load over effort, and the load is given as 300 newtons. So 300 newtons over effort equals 120 over 100. Now, what this implies is that we can solve for E by saying E equals 100 times 300 over 120. So let's break this down. If 0 cancels 0 here, what can go? From here we can see that 3 goes here 4 times, 3 goes here 10 times. So 4 here 1, 4 here 25. So what we have is 25 times 10. So effort equals 25 times 10 will give us 250. So 250 newtons. That is option C. If the velocity ratio of a machine is 4, what does this mean? Now, folks, if you're yet to subscribe to the channel, I would like to implore you to please do so. It's only going to take a second of your time. Just hit the subscribe button and also click the notification bell icon so that you get alerted every time we put out a new content for you. And also, let me mention that you can also practice with the Exam Fund app. We've dropped the link to download the app in the description box, so please find it there, click install the app, and make your learning experience a whole lot more fun. So to solve this question, we are going to consider the velocity ratio of any machine. Okay. Now, what we know about velocity ratio, VR, is that it is the ratio of distance moved by effort. So distance moved by effort to the distance moved by load. And we are told that this equals 4, right? So if we're going to linearize this part here, we just cross multiply and take this to the other side. You then see that distance moved by effort equals 4 times distance moved by load. And the option that describes that is option B, where we have distance moved by effort is 4 times greater than distance moved by load. So the correct option to go for is therefore B. An effort of 40 newtons is applied on a machine to lift a mass of 60 kilograms. Determine the mechanical advantage of the machine, taking G, which is gravitational acceleration, as 10 meters per second squared. Now, mechanical advantage, MA, is load over effort. So let's apply that. So we can then say mechanical advantage equals, what is the load? The load has a mass of 60 kg. So note here, load is mg. So mass 60 kg multiplied by acceleration due to gravity, that's 10. Now all divided by the effort applied, which is 40. Okay, now this would give us 600 divided by 40. So 0 cancels 0. So we have to divide 60 by 4. So mechanical advantage therefore is 15. So the correct option is D. The velocity ratio of an inclined plane at 60 degrees to the horizontal is, now to solve this, velocity ratio of inclined plane is 1 over sine theta. So therefore velocity ratio VR equals 1 over sine 60 degrees. That is, we have 1 over sine 60 degrees will give you 0.866. And when you divide that with your calculator, you will arrive at 1.1547 and on like that. So, and this is approximately 1.155. So the correct option to go for is option B. This question says, a plane inclined at an angle of 30 degrees to the horizontal has an efficiency of 60%. The force parallel to the plane required to push a load of 120 newtons uniformly up the plane is, now let's consider this to be the plane, right? And this will be the distance moved by the load. And then we have this angle here where we have 60 degrees. And then we have the load here. And the load is 120 newtons. Now, the force that pushes it is the effort in this case. So that is what we're going to use to find it. So we need to find this effort. So here's our solution. The efficiency is already given as 60%. So if the efficiency is 60%, that will be 0.6 equals, now mechanical advantage over velocity ratio. Now let's find the velocity ratio. Velocity ratio is 1 divided by sine. Oh, this is 30%, 30 degrees I mean. From the question, it's 30 degrees, not 60. So let's apply that there. That will be 30 degrees. So from here, we can then say 0.6 equals mechanical advantage over sine 30 degrees is 0.5. And 1 divided by 0.5 will give us 2. So we can now say mechanical advantage equals 2 times 0.6, and that will give us 1.2. Now, mechanical advantage itself is load over effort, and that is now 1.2. So since we have to find the effort, that is effort becomes load over 1.2. And the load is given in the question as, let's read through the question again. The force parallel to the plane required to push a load of 120 newtons, so that is 120 newtons, divided by 1.2. So we can then say effort equals 1,200 divided by 12, and that will give us 100. So 100 newtons. The correct option is therefore option B. A wheel and axle have radii 80 centimeters and 10 centimeters respectively. If the efficiency of the machine is 0.85, an applied force of 1,200 newtons to the wheel will raise a load of, so we have to find the size of the load now. So solution. Efficiency is given as 0.85, and this equals mechanical advantage, which is load over effort. Effort is given as 1,200. And then all of this divided by velocity ratio, which is the radius of the wheel over that of the axle. So that will be 80 divided by 10. So if we break this further, we're going to be having 0.85 equals load divided by 1,200 all over 8. And what this implies is that load over 1,200 equals 8 times 0.85. So from here we can then say load equals 1,200 times 8 times 0.85. Now you can go on to compute this with your calculator. It will give you 8,160 newtons. So the correct option is option C. A machine requires 1,000 joules of work to raise a load of 500 newtons through a vertical distance of 1.5 meters. Now we have to calculate the efficiency of the machine. Now in this question, you see we are not given mechanical advantage of velocity ratio. So we're just going to use the plain equations for efficiency of a machine to solve this problem. Solution. In this case, the efficiency would then be work output of the machine over work input multiplied by 100. So now what is the work output of the machine? That is the work done by machine. And that work is the machine raised a load of 500 newtons. That is force or load, 500 newtons times distance. Remember that work done is force times distance. So this is force, then times distance of 1.5 meters. All divided by the work put into the machine, that is the work input, that is 1,000 joules. All of this multiplied by 100%. So what do we have here? This would give us 750 joules over 1,000 joules. So joules cancel joules. All of these times 100%. So 0 cancel 0, 0 cancel 0, 0 cancel 0. So what we have is 75%. And that is in option B. Calculate the velocity ratio of a screw jack of pitch 0.3 centimeters if the length of the tummy bar is 21 centimeters. Now, one thing you have to take note of when you are solving a question involving screw jack is that sometimes they often give them in different units. Like this is in centimeter now, the pitch could have been given in millimeters. So before you solve, it's either you convert both of them to millimeters or you convert both of them to centimeters and then solve. That way you would not make any error. But in this case, we have them in the same SI unit, so we can just go on to solve. Now, the velocity ratio of a screw is given as 2 pi r over pitch. So this will be 2 pi multiplied by the length of the tummy bar, which is 21 centimeters, all divided by 0.3 centimeters. So centimeter cancels centimeters. What we have here now is, this is 2, that's 42 pi divided by 0.3, which is basically the same thing as saying 420 pi divided by 3. Now, what does this give us? 3 in 4, that is 1, remember 1. In 12, that is 4. In 0 is 0. So 140 pi, which is what we have in option D. Now, folks, to practice more questions on simple machines, you can download the Exam Fund app. You will find the link to download the app in the description box of this video. Kindly click the link, download the app, and make your learning experience very much fun. And as always, don't forget to share and like the video. You just might be sharing it to someone who needs this video to ace Jamb Physics. Thank you very much, and I'll see you in the next video.